Welcome you all. Now we discuss about the kinematics of machinery. Especially kinematics of machinery deals with the relative motion between the various parts of the machine and forces act on the machine parts. Now our first chapter is mechanism and machines. We discuss the important formula and equations of the about the first unit. Number 1, the required equations are conditions to form kinematic chain are n equal to 2p minus 4, j equal to 3 by 2 n minus 2 and j plus h by 2 equal to 3 by 2 n minus 2. Here, first of all, we consider what is kinematic chain. Please go through this. This is a reciprocating steam engine mechanism. Right side we have flywheel and crank. So connecting crank is connected with the connecting rod, and the connecting rod is connected with the cross head piston. Then finally the piston is connected in the cylinder. The mechanism converts rotary motion into reciprocation and vice versa. Particularly we consider 4 important things in the element in the kinematic chain mechanism. Number 1, kinematic link. It is a resistant body. During the force transmission, it can't this not undergo any deformation. So this is called kinematic chain. Next one is kinematic pair. So the kinematic pair means number of links are joined. Particularly 2 links are joined. That is called kinematic pair. The condition is the kinematic give the relative motion. That is important. And another one is kinematic chain. The chain means number of kinematics are coupled. Number of kinematic pairs are coupled in such a way that forms a long chain. That is called kinematic chain. Finally, mechanism. The mechanism is one. Which one is in a kinematic chain when one of the link is fixed. That is we called as mechanism. Now we go through the problems. Before going through the problems, we consider the formulas first. The required equations are conditions to form the kinematic chain. So condition for a kinematic chain is n equal to 2p minus 4, j equal to 3 by 2 into n minus 2. So here n equal to number of links, p equal to number of pairs, and h equal to number of higher pairs. Next formula, kliens construction of constraint to determine the nature of chain. First we discuss 3 kinematic chains. Number 1, left hand side greater than right hand side, it is a locked or structured chain, and left hand side equal to right hand side, it's a constrained chain which gives the definite motion. And third one is left hand side less than right hand side, it's a constrained chain, unconstrained chain. So the kliens constraints gives the nature of the chain, j plus h by 2, that is equal to 3 by 2 l minus 2. Here the Grublers, or next formula is Grublers equation for planar mechanism. Grublers equations for planar mechanism. Here the degree of freedom equal to 3 by 3 into n minus 1 minus 2l minus h. Here DOF means degrees of freedom, and L equal to number of lower pairs. If the degrees of freedom equal to 0, the device is statically determinate structure. Simply degrees of freedom 0, it's a structure, and degrees of freedom greater than or equal to 1, mechanism with constrained motion. Here degrees of freedom greater than 1, mechanism with constrained motion, and degrees of freedom less than 1, statically indeterminate structure. Finally, the Gussbach criterion equation for spatial mechanism. Here the degrees of freedom equal to 6 into n minus 1 minus 5p1 minus 4p2 goes on. So n1 equal to number of links, p1 na number of pairs with 1 degrees of freedom, p2 means number of pairs with 2 degrees of freedom. Here in first unit you find out the first of all what is it's a kinematic chain or not, and links, number of links, number of joins, and Grublers mechanism and pushback criterion. Now we shall go to the problem. Solved problems. Consider if three arrangement of three links. Here the number of links equal to L equal to 3, P equal to 3 and J equal to 3. Links means L1, L2, L3, and pair means link 1 and 2 joined at B, that is called one pair. Like this we have three pairs. So the formula for first formula kinematic chain n equal to 2p minus 4. So 3 into 2 minus we got left hand side greater than right hand side. So this is a left hand side greater than right hand side. Now it's a locked chain. So first structure is not a mechanism, it's a locked chain. This is particularly 4-bar mechanism. So particularly 4-bar mechanism. Here it's link number of links equal to 4, pair equal to 4, joins equal to 4. So the equation is L equal to 2p minus 4 now. Left hand side equal to right hand side. The another equation also satisfied. Left hand side equal to right hand side. Right? So the satisfy the equation 1 and 2. It's a kinematic chain of 1 degrees of freedom. Next one is 5 link structure, 5 link arrangements. In link equal to 5 and pair equal to 5, joins equal to 5. The link, the formula is L equal to 2p minus 4. So we got left hand side less than right hand side. It's a unconstrained chain. So this type of structure is called unconstrained chain. Next topic is types of joints in a mechanism. In this joint we have binary, ternary, quaternary joints. Binary means at A, two links L1 and L5 joined at A. So this is called binary joint. Two links are joined at one connection, that is called binary joint. And ternary means three links are joined. Ternary means three links are joined at one connection, a ternary joint. And quaternary joint means four links are joined at quaternary. One single point is called quaternary joint. Remember, one ternary joint equal to two binary joint and one quaternary joint equal to three binary joint. Now we go for problem. Here is a structure, arrangement of link. Here the number of binary joint is 1 and number of ternary and number of quaternary joint. So the total number of links equal to 15, joints equal to 15. So the formula is J equal to 3 by 2 L minus 2. So we got left hand side greater than right hand side. It's not a kinematic chain, it's a locked framework structure. Here you see the 4 binary joints and 2 quaternary joints. That is the idea, just you find out this. So in this case we have removed CG, the link CG is removed. Then we got 10 links and one binary joint at D. So total number of links total number of binary joint equal to 1 plus 2 into 6, 13. So the equation is left hand side equal to right hand side. So suppose the link CG is removed, then this structure will comes to the mechanism. So here my idea is little bit discuss about the simple concept behind the kinematic chain, and in future we cover all the things. Thank you.